Hey, stop saying Rust is complicated. Rust often gets labeled as too hard or too complicated because it forces you to think carefully about memory concurrency and error handling. But here's the catch. Those aren't just Rust problems. They are software engineering problems that show up in any sufficiently complex system. Isn't that? But I thought the literal trade-off of using something like Go or JavaScript or Lua or Ruby was that you don't think about those things. Right? Isn't that the purpose of a garbage collected language? Is that you don't actually think much about memory at all? I mean, at least those node processes using several gigabytes don't seem to be maybe they think about memory a lot because they certainly use a lot. Maybe I've been wrong this whole time. Maybe Node really just thinks about memory all the time and they love it. And now we just have that. That could be it this whole time. You know what? I've been wrong. I'm sorry. I'm wrong. I'm the wrong one. It is true, though. Everything that is being said currently here is very, very true. Is that there's software engineering problems that show up in any sufficiently complex system? Absolutely 100% true. Obviously, memory concurrency and error handling are all things that exist no matter what. Like if I were to make what I'm making right now in my whole Go program, but making it inside of, say, Zig, I'd have to figure out how to do my own green threads, right? I don't know how to do green threads in Zig. I don't know how to do kind of that task handling world, right? With Rust, I'd use Tokyo, and I just wrap everything in an arc mutex. Complicated? No. Verbose? No. Slow? Probably, because I can't write good concurrency in Go or in Rust very easily. Error handling? Error handling is fantastic in Rust, though I will say this. Can I say something that's going to make people upset at me? Yeah, you guys are going to be upset at me. I think I like Go's error handling in some sense better than Rust's. Let me tell you why. I know a lot of people just hissed. I think I heard some hisses. Okay? Let me just tell you why. Just hold on. Just hear me out just for 1 second. It's not because I don't mind audible gasp. I do not mind result objects. I think result objects are pretty fantastic, okay? So it's not about result objects. But I've seen this a lot in Rust, is that people don't like handling their own errors in Rust. So what do? Use anyhow result. Okay? Hey, this is me too. I know we're in Go right now. Just follow along with me. You have some sort of function, foo, that returns a result like that, okay? This is you, right? This is you. And then you will do something like this. Let's call it async. Let's say you're using something like request, right? Request. You'll do something like get. You'll do something like get. Something like whatever it looks like to get that all done, right? Because there's like some things you have to do to get that all done. And then you'll have a question mark because you're going to just return the error if it doesn't work. And then you'll do something along the lines, right? I don't know. Let's call it request. I can't remember what the thing's called. You'll do a request, and then you'll do a dot, and then you'll do text, and then you'll do a dot. Then you'll do this, and you'll go like that. You'll go first. You'll go like this. Await that, and then you'll do await that, and then you'll do some other thing on top of it to get it all out, right? You do this. And what's actually happening here? You're actually handling several different paths of errors all happening at the exact same time. Right? Like that's kind of weird, right? There's a lot of different paths that are all happening at the exact same time. And so what I end up seeing is that every single function, at least with some of the code that I've looked at, and maybe this is just a me problem, is that every error is just a question mark. And every error just pretty much goes just zipping almost practically up to the straight up tippity top of the program, which makes it kind of difficult sometimes to read. Whereas with Go, due to a bit more of the verbosity, I find that I kind of make more concrete decisions about every error at the exact spot. I'm not saying it's good. Sometimes I prefer Rust's approach for sure. But I take a bit more things. And yes, people are saying, well, with anyhow, you can also do context, right? So then when you do that, you can also do context failed at sending the request, and then you can hit it with one of those. I do understand that. I'm not arguing with you. I'm just saying that I've seen a lot of error handling that comes out in kind of a goofy way because of how easy it is. That's all I'm saying, is that sometimes the intentional verbosity is nice because I think a bit more about every single positional error. and why it exists. I don't think that's a skill issue. I think that's an obvious way. Anytime there's something that's really easy, it will be used sometimes too much rather than not enough. I think that's completely reasonable, right? Just saying. Completely reasonable that when something is super simple, it tends to get used more than it should, just because of its easiness. That doesn't mean it's good. It just means that it's easy. And if people all used it really nice, that'd be great. It sounds reasonable, but it's not. No, you guys are just lying to me. Okay, anyways, I do like this. Okay, let's keep on going. All right. Rust's approach may feel strict, but it's essentially teaching you fundamental best practices that lead to more reliable, maintainable code. Let's break down why. I also I don't know about the whole reliable, maintainable business. I think you can write just as many bugs and have just as many problems. I will say, though, that Rust's handling of channels, I think, is far superior than Go's. Okay? Obvious reason why is that they have an options object. So you know when the channel is actually getting none versus it's getting an empty thing, which I think is very, very good, and I think Rust did a great job with their channels. By far, much, much better than Go's. But I will say that Go's syntax is just so much nicer. They're so much nicer comparatively to the use of channels is so much nicer in Go, but channels definition is so much better in Rust. It's not Rust, it's software engineering. Here we go. Experience, I have no idea. Yeah, this is like the chart of disillusionment. I don't know this is true in anything you use, right? Go is easier to reread weeks later. Typically, Go is really, really simple, right? Is Go a direct descendant of Lua? It sometimes feels like that. Rust includes many features like option, result, traits, algebraic types, array that people sometimes describe as complicated, but these concepts aren't unique to Rust. They are borrowed or refined from decades of programming language research or practice. In other words, Rust is simple packaging and essential software engineering concepts into the language, making it hard to ignore. Yeah, but also like, right? I'm not saying this is somehow, this is obviously meant to be tongue-in-cheek here, but at the exact same time, you can't necessarily say that there isn't. Oh wow, nice image. Rust, you have like a cajillion strings you have to think about and why you use each one, because each one can be used slightly different. The reason why there is, say, a path buff as opposed to a string that's used for paths for files is because not all files can technically be encoded in UTF-8. They can actually be encoded outside of UTF-8. So Rust puts all that safety in there, which is good, but also it can be very, very annoying. And yes, this guy's fully Mark Zuckerberging and just pointing straight to her tits. He's not even pointing this. Very inappropriate, Mark Zuckerberg. Very inappropriate, Mark Zuckerberg. So it's like, is it complicated? No, but what do you call complicated? Is complicated needing to remember a bunch of things to be able to use the language, or remember a few things? What is complication? And so I think that's the big argument here. I think that there are some things about Rust that are very complicated, right? I think there's some things that are very nice. Like when you create your own iterators, it can get kind of complicated, okay? Go doesn't really have iterators, which creates complication in different ways, but that ends up just being a for loop and a couple things, and then you can use some of the generics and it kind of works, and so it's like not all that bad, and it's just like it can be that way. Rust is pragmatic but pedantic, right? And so it's like I'm not arguing. These things are all good, but they can also lead to complication. I also find that often what I'll end up do is that I'll end up trying to like really define my types, start building something, realize I need to redefine my types, and I find myself doing this swirl with types and definitions and how things are passed around, and I find that lifting sometimes is a pain in the ass as opposed to just being the thing. I'm not exactly sure where I'm landing on these things, right? This is why right now I'm doing this whole message business where I'm kind of feeling my way out through Go, using generics to kind of create this interface that makes it a bit easier to be able to listen to specific types of messages. Just kind of thinking through that. Kind of an interesting way to kind of go about it. That which is complex is not inherently complicated, but complications always lead to complexity. Philosophers can weigh in. Yeah, it's hard. It's very, very hard. Here's a quick rundown of some key features where they come from. Option result. By the way, I do love option result. I think Zig did this really, really well. but I also think that Rust did it pretty well. But I think I like Zig's a bit better because it just feels lighter. I'm not really sure. Influence. ML Haskell's maybe or either plus error handling paradigms and other functional language and system designs. Why it matters. These types force you to handle cases where data may be missing or operations can fail, preventing null pointer exceptions and unhandled errors. True. Very, very true. There are some, I mean, this is one thing that I love about, I'm going to say this, and this is going to make people upset. One thing I love about TypeScript, I know, is when you have a type, right? Let's just say there's a type like this, and it has a bar that's some type, right? It doesn't matter what it is, right? It's some type, okay? We've all seen this. And if I have a foo, if I have a function that takes in a foo that is a foo, and I start writing this, and I go like this, if foo bar, if not foo bar, right, then what's it called? Return, right? Sorry, this thing can't indent because I'm mixing Go and TypeScript. It doesn't really matter. If I do that, from here on out, foo bar is just defined, right? That is a cool thing about TypeScript, and that's obviously because you had to do a runtime check to make that. It is really nice. I like the fact that I can kind of go through that. I know I understand the limitations and why this makes sense. There is something pretty cool about that experience, okay? I'm just saying it can make code feel very easy. PHP does this too, yes. There's languages that do this as well. It is a very nice thing, these type guards, and I find them to be very convenient to work with. That's just that. Okay, algebraic data types and pattern matching. Yep, pattern matching seems to be pretty OP. Pattern matching definitely is a much sorely needed thing in a lot of languages. I feel like you can solve so many problems in very unique ways using pattern matching. I just don't quite know how to use it well. You know what I mean? Traits seem pretty great. Traits also kind of big pain, right? Once you get into traits that involve like good performance, especially across bounds of like async, then they seem to get really difficult. But like traits themselves seem really great. Like, I mean, can we all agree interfaces are great? Right? Like, I think we all can agree that interfaces are fantastic. We all like interfaces. I like how Rust uses the interfaces. I enjoy how Rust did it. I like how Go does it as well. I like being able to attach methods to types after their definition. I really think that this is the superior way to do it and to be able to fulfill this. I think Go's usage of interfaces as just kind of like duck type style is really, really cool. I think it's really, really cool. Obviously, it requires a vtable and all that, blah, 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 but I actually really like it. And I think I'm also super missing out on Zig because I think Zig can do like comp time interface static dispatch, and I just don't know how to do it. And so it seems like there's something really amazing about that. So I'm just kind of talking about languages in general because I've actually just become a big fan of looking at a lot of languages. I think things that Rust did are fantastic. It just doesn't bring me joy. I'm kind of, I'm slowly becoming a different person. You know what I mean? I'm going to be right back, okay? I'm going to be right back. Be right back. Hey, hi. I know this is a talk about Rust being complicated. I just really wanted more coffee. I'm sorry. I just really wanted more coffee, okay? I'm feeling a little coffee envious right now. Dog, dude, I had to get up so early. Well, actually, I didn't even get up that early. I went up late. Oh my gosh, my thing is breaking down. The kids who also ruined my, threw my crap everywhere. The ones that kind of broke my place also broke my microphone holder a lot more. And I can't even get this thing to be tight anymore. I have to go buy. Anyways, needless to say, I am not the most impressed this morning. And then gosh, G-dang. I'm just G-danging right now. Okay, that's all I'm doing right now. Send invoice. All right, so. Like all these things he's talking about in here, algebraic data types, they are kind of complicated. Pattern matching. See, I think one thing that people do, and I think this is something that people have a hard time relating to people who aren't like new to something, is that when you have gone through all the different learning processes, things feel simple every single time. And when you're used to something, it feels easy, trivial, not a problem. And so the more you become good at something, I think the harder it is to relate to people who aren't good at something. It's the curse of knowledge, right? And so, in my personal opinion, I think that JavaScript has gotten to the point where it's more complicated, especially just with proxies and everything. Like, the more things that can actually happen, decorators, like the more and more things that happen, I think make it more complicated. I think C++ is complicated. I think Rust is complicated. I think Go and Lua are simple. I think Zig is somewhere between simple and complicated. I think that Jai is going to probably be complicated. C sharp probably falls closer on the line of. The problem is I think C is simple. I think C is extremely simple, just because I judge simplicity by what you need to know to understand it. Now, that doesn't mean using the things are simple. I think that Go leads to complexity, which is different, but I think Go itself isn't complicated. I think Rust is by far more complicated. There's a lot more things you have to know inside of your head to do something. Like when you want to compare objects, if you want to put something into a hash map, you have to learn what a partial ordinal is. Okay? Most people don't use the phrase ordinal in their average life. Even programmers. Partial compares. It's like there's a lot of things that have to go in your brains to understand stuff. Right? But Rust's whole goal is that it makes certain aspects of programming simple by reducing your ability to express within that domain. And I think that's what he's trying to say. Ray's great. Obviously, it just means that when something constructs, it makes sure it has all of its memory, and when it destructs it makes sure it gets rid of all of its memory, right? That's how Rust works with dropping, right? For those that don't really understand the borrow checker, it's actually, or not the borrow checker, how the dropping system works, it's actually pretty simple. Rust exists in two places, right? This is also where some of its, I think some of the complexity stuff comes in to being. Hold on. Here we go. So there's the stack, and then there's the heap. Some objects you create in Rust have a stack component that points to a heap component, right? So you can think of something like a vector. A vector has a stack component, which is going to be a pointer, it's going to be a length, and it's going to be a capacity. Pretty straightforward, right? And then the heap is where the stuff is stored, right? Okay, so you get the idea. When something is on the stack, you effectively just, you go downwards, and when it's done, the stack pointer goes upwards. When the stack pointer exceeds this bounds, then this thing is cleaned up, and anything with a heap pointer gets cleaned up as well. That's all, that's really how you can think about that. This is Rust's version of Ray, right? Function Ray is all it is that it's allocated up here. Whatever's on the stack gets allocated, and then also whatever's on the heap gets allocated. And when this thing runs out, it just automatically gets dropped at the bottom because the stack goes away. This is how RCs work as well. If you really think about it, every time you create a new stack item, it increments some sort of something behind the scenes that until that thing gets to 0, it can't get dropped. So even though it goes away on the stack, when it drops, it just decrements the number. And when that number reaches 0, then it can drop it fully. Right? So it's actually really it's not, when you get it, it actually makes a lot of sense when you think of it as stack heap, right? Zero cost abstraction. The cost is emotional complexity, right? C++, why it matters. Rust abstractions, iterators, generics, closures don't add extra runtime overhead compared to handwritten low-level code, encouraging both readability and performance. That's true. It is pretty cool that you can use iterators, and those iterators can, if you just do a for each, they actually get unrolled. And that's pretty cool. There are costs. It's not a zero cost abstraction. One of the big costs of this abstraction is obviously going to be compile time. That's not a free item. So when they say zero cost abstraction, they're only purely talking about performance, but there's definitely some things you have to trade off. And if you've ever worked in a very slow compiling system, you know that it's not fun, right? You don't just like, oh, this is fun, right? Like it can be annoying. Yeah, it builds up in its own unique way, right? Blue hair dye costs a lot too. Yeah. Concurrency, Erlang, this one. Why it matters. Rust strict aliasing and ownership rules make concurrency mistakes hard to compile, leading to fearless concurrency and fewer data races. Yeah, this is great. I actually generally like Rust stuff when it comes to concurrency. The fact that every time you try to do something and it turns into, I only know his name is Newman from Jurassic Park, where he goes, right? Oh, you got to wrap it in an arcmutex. I actually really enjoy that, generally speaking. And the reason being is that almost always whenever I have a oopsie daisy with the data race, it's because I forgot to create a mutex to prevent the data from getting owned, right? Whoopsie poopsies, my bad, right? Right. Yeah, I agree with that, right? Newman from Seinfeld. Yeah, Newman from Seinfeld, right? And so it's like, I like that. I think this is one thing Rust did really, really well, and I wish Go kind of had some way in which they could potentially lint it, like a function is called from within a Go func and from within the Go func and without the Go func. It'd be nice if it had some sort of like, hey, just so you know, this is a Go warning. You might have yourself, you might have yourself an oopsie daisy. It'd be kind of cool. Examples in Go versus Rust in handling no value. Let's use one of these features, Option T, compared to more traditional approach of Go's nil. For users, get ID, user, this one, do this thing, nil. Users, if user equals nil, return, do this. Let's do that. Okay, so that's Go, right? In Go, in other languages, it's up to you to remember to check nil everywhere. Miss a check, and you could trigger a runtime panic or crash. Correct. User, this one, you have to do an option, right? By the way, the forced if-else, it's because they don't have a return. You can just put a return, then you don't have to have an else. I don't like that. Hey, that's complication. Hey, just saying. Have you ever looked at a multi-line return statement with ifs as the last thing? I don't like that. Just saying. Then you can do this, right? This is neat, right? Forced checks. It is true. No one try to argue me that this is not true. Don't even dare try it. It's yucky. Right? I don't like that. Is the Go one better? I don't know. I don't think the Go one's better. I will say this is that not all pointers need to be checked. Right? Not all pointers need to be checked. And this is where this is where asserts and robust testing, simulation testing specifically, can really help create a good world. If you know what I mean. I like that. And so then you can kind of get rid of these things. And because almost every time I use nils, it's because there's usually an error here. So one thing that he's missing here is that typically in Go, this is usually because you're actually creating a by hand results object by having an error as the last argument and then this. And so it's a little bit different. But yes, I get the idea because typically that's where you would do those things. This guy's writing bad Go code. I mean, the example is meant to be trivial. Let's not try to focus on that. What he's trying to say is that when there is a nil, you need to explicitly check for nil. The compiler does not warn you, hey, this thing was not checked for nil. We can agree. I really do. I really, really, really wish Go introduced a question mark there. Honestly, I really wish there was something that's hey, I want to let you know that this is a pointer that could be null, right? Something that just tells the user that there's a danger here. I would love to see that. I would truly love to see that in Go, because not all pointers are going to be nil. Some are never just going to be nil, ever, for any reason. And sometimes they do that. Chuckles, I'm in danger, exactly. And sometimes you do have that. Any pointer can be null, surely. That's not always true. What I mean by that is that's not always true. It's just simply not always true. Sometimes you have parts of your program that if it were null, it's because there's an invariant in your program that has fundamentally broken and your program is just full ass broken, right? And so it's not all pointers are nil. Not all pointers can be nil, right? Some nils mean that you have a fundamental oopsie daisy within your program. Magoo, appreciate that, right? All right, let's see, 2. It's a learning curve or bugs in production. Also, don't agree with that. Right, I don't think that there's I don't think it's either or here. Yes, Rust makes you jump through the hoops for error handling, result T, memory safety, ownership in this, concurrency. But if you're not doing those checks in other languages, the bugs don't magically disappear. They lurk in your code without manifesting the worst. Absolutely. Simulation testing. I love simulation testing. I've been a big fan of it. Again, what I write typically tends to be smaller stuff, and I've already started to set up my little program that runs all my stuff through here. I've already started to set it up so that I can do simulation testing. So I can just start just piping stuff through and forcing all the program to run, a million kajillion times in a very small period of time just to really test things out, which I think is going to be fantastic. But no startup is going to simulate testing their working product. Yeah, and no startup should probably use Rust either, right? Like if your goal is to run as fast as possible, I don't think Rust or simulation testing is probably a good idea, right? I think we can both agree to that. Like maybe that's not it. Okay, but the problem with this is in the real world is it's actually 100% okay a lot of time to have lingering bugs. And to be completely fair, Rust does not prevent all bugs. You still have plenty of logic bugs. I have not tried property-based tests yet. No, I honestly don't even know what that type of test is. Startups tend to just need to run very, very fast. Go, TypeScript, bug-free software. How do you know there's a bug when you do? So what I mean by this is just simply you assert the invariance in your program, both positive and negative space. This pointer must not be nil. There shall never be a nil here. I shall never experience an error in this one thing, even though it says an error, right? Like something that I should never have is, let's say I have a internal communication that expects certain behavior. If my service just stops responding with, say, JSON, that's just a fundamental error. Like that's, what do I do with that, right? I can no longer use that service anymore, which renders me, useless. And so there's like a whole problem there that you have to kind of figure out. Right? Isn't that what Rust type system is effectively doing? No, because it doesn't tell you how you should handle that. Right? And so this is where you can run all the different cases. Right? Rust type system in some sense is definitely doing that. Options kind of help you do that, but not all options are useful. Right? Sometimes you just know you have a pointer, but the pointer is just not it's always there. It has to be there. Right? You cannot not have it. Right? Null pointer exceptions. Languages like Go, Java, or JavaScript often run into nil or undefined issues. Rust options eliminates this entire class of bugs by design. Yeah, it adds in more code though. Can we all at least minimally agree it does add in more code? You always have to lift. And this is one of those things that kind of made it so that I quit having as much love for programming Rust, is I constantly found myself lifting. And lifting is great and all. It does help me prevent stuff, but man, it can get really frustrating when everything is a lift. Like everything is a lift. You know what I mean? Lifting is good for your health? Hell yeah, brother. Do you even lift, bro? Would you rather spend a few extra minutes satisfying the compiler's requirements or spend hours debugging some random crashes? I don't think this is a trade-off that most people make. I do think this does happen, though. It is fair, but I don't think that it's really as either or as people make. Do you know what I mean? I think that, I just don't, like, most people are building, like, pretty simple applications where this is just like, this isn't even an issue they can actually do anything with. In fact, I bet you Rust is probably more beneficial for me due to the fact of the complexity that I'm building here, right? I just don't think that's, and it's not a few extra minutes. It can be definitely not a few extra minutes. You realize that you fundamentally represented your program incorrectly and you have to do just a massive sweeping change. And if you've built your program also for performance, you can have lifetimes tied to a lot of these sweeping changes, which just causes a whole bunch of, again, I think this is one of those things where you get too much experience in a certain topic and you can forget the pain of what it's like to be new, right? Also, I mean, I do think web development seems a little strange for this. Embedded, this seems reasonable. CLI tools, completely reasonable. Blockchain, I don't know. They also use Haskell. I don't know what to do that. Performance critical, that seems fine. That seems fine. Operating systems honestly seems like your best argument for Rust. I want an operating system that can never have this kind of memory oopsie daisy. That actually seems like the best. Like, that truly does seem like a really great thing. AAA games, I'm really doubting the whole AAA games thing and Rust. Yeah, we'll do Bun next. I'm just not purchasing this as a real thing. Right? I just don't. All right. Let's see. Yeah, but lifetimes. Let's address the big elephant in the room. Lifetimes. Yes, they can look scary in function signatures. However, most Rust developers will tell you that over the past few years, the compiler has gotten much better at inferring lifetimes automatically. You rarely need to annotate them manually unless you're writing generic or complex code. Yes, like referencing a string in a struct. I didn't find lifetimes that hard. They're not hard to understand. They're hard sometimes to write well. Yeah. I mean, let's just be real. I assume game devs do this. Okay? Just call me out if I'm incorrect. Game devs do this. They create a bunch of arenas based on different lifetimes of objects. And they just linearly allocate these arenas. And then they're just like, all right, all done. Go back up here. Everything's just dead. And they just run this lap in a bunch of different arenas based on different stuff, like bullets, right? Bullets, you should just create a whole bunch of, and then just go, okay, done. Stupid, done. Because, like, bullets can only live for, like, so long, right? Like, they're not that long. And so it's just like, bam, 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 bam. Get the hell out of here. I assume these things exist. I don't know exactly how they exist, but they probably exist in some. Right? And so it's like, why have all this stuff? Just memory pool and just get the hell out. Right? Yeah, I don't think understanding lifetimes is very hard. The syntax is a little bit goofy. I don't think, like, none of those things are the part that whenever someone says lifetimes were kind of easy, I agree with them, but I don't think that's the problem. I really don't think this is the problem. Okay? To me, this isn't the problem. The problem is very, very simple. You have a program. It's moderate size. Let's say 5 to 10,000 lines of code. Okay, that's actually a pretty sizable little program. Can we all agree to that? That's when you have to make a sweeping change, there's a decent amount you have to do. Sizable little program, 10,000 lines. Okay, you're managing this little tool. It's at your job. There you go. That's on the smaller size. Yeah, but it's still big enough that a bunch of problems kind of show up, generally speaking. You actually have to be more aware of design. When things are below, like, say, 2,000 to 3,000 lines of code, like just a small internal tool for releasing or building or doing something, you don't even have to care about, like, the shape of the code. You can just dunk that crap in, right? When you're at about 10,000 lines, 5 to 10,000 lines, now you have to really start being a bit more concerned about the shape of your program and adding stuff, or else it gets very difficult. Okay, so now that we have that, the thing that I think is that they don't speak of right here, or whoever writes this blog does not speak about, is that when you have to refactor your program due to adding in a new lifetime, sometimes you find yourself having to color functions all over the place, and it, like, has this whole, like, explosion effect where once your program was really simple and now you went from nothing having lifetimes to a bunch of things having lifetimes that you were just not prepared for, and now you have to change some orderings, you have to rethink about how things happen, and so lifetimes aren't hard until that happens. Then they're hard. Then it's a pain in the ass. Then it becomes something that you don't like. And so I don't want to hear that lifetimes are easy because, yeah, typically you just never even think about it. Honestly, Arc Mutex, RC RefCell, throw that crap in a clone, right? Like, just enjoy that life because that's typically way easier. That literally just happened to me. Yeah, and it's kind of painful, right? Can we agree that when it does happen, it can be a bit painful? Yes, there you go. Obligatory. This is effectively the Rust lifetime meme as well. This is an async function meme for coloring functions, but Rust has two types of colors, right? Async and lifetimes. And so when this happens, you could oopsie daisy your program and just be like, lifetimes, right? Because of this. right? Whoopsie daisies. Whoopsie poopsies. So, all right. It's more important than ever. 5. It's more important than ever. With the rise of AI coding assistants, Copilot, Gipity, all this, we're generating more code automatically. That's convenient, but it also means we're risking injecting subtle bugs into productions without a second thought. A strong type system, one that enforces ownership, borrowing, and explicit error handling, is your safety net. Let's see. AI-generated code can be logically correct, but still miss real-world edge cases. This is true but Rust doesn't save you from that. Rust compile, it just saves you from like the simple stuff, like don't access a nil. Dog, you're not allowed to do that. Let's see, systematically enforces invariance, saving you from an entire category of bugs. True and factual. In an area where coding becomes automated, having languages that stand in your way for the right reasons become a huge advantage. I still think you can get a bunch of bugs, right? Like, I don't think this is... I've always disliked this reliance that somehow you just write less bugs. I think you write mostly the same amount of bugs. Just throwing that out there, I think you write a lot of bugs. Conclusion, Rust isn't too complicated. It's just intentionally strict. Okay, that's fair. Too complicated. Fair. Rust isn't too complicated. It's just intentionally strict. It's a language that wraps core software engineering best practices like handling null values properly, preventing memory corruption, and forces deterministic cleanup into the compiler. Yes, there's a learning curve, but the alternative is shipping code to production with hidden booby traps. I don't know if that's always the alternative. See, that's one thing I don't like is this type of thinking around programming, because we can say this. If you've used Zig, alternative to Rust, in some regards, you can claim this as an alternative to Rust. It has an idea where you can go like this, where you can do, I think it's fun, I forget its function, right, foo, and you can return out of foo an optional, thing, right? Or technically, you can do this. And I forget the exact thing. This is an optional. So you can write this thing as like, hey, this thing might not exist. You need to check it out before it exists. Now, it doesn't have all the ownership semantics. It doesn't have all those other things. But it gives you a good amount of like safety in the cases where you know that there's an unsafe procedure happening. It also does it with errors. You can also do error unions, right? And it has a bunch of that stuff. Stop shilling Zig if you never use it. First off, I wrote a video game in it, and it was fantastic. Had a lot of stuff happen. I had a great time. Second off, Isaac, you are allowed to shill something because you enjoy using it, buddy. Just because I spend my time investigating other languages, what are you talking about? Why do people have to be this way? Why do people have to be this way? Video game, yes. I mean, granted, it was an ASCII game. Hey, you can still return a stack pointer. Yes, this is true. You can do this, and I did do this. To be fair, Zig allows that to happen, right? I'm investigating languages such that I can show people what's coming into the future. My goal is to show you what's available and what potentially the next 10 years could have available to people to use for either side projects or professional projects. Now, you may be angry about that. That's up to you. It's the same reason why, I think that, like I said, I think there's plenty of great reasons to use Rust. It doesn't mean I just love using Rust all the time. I personally would not use Rust if I don't have to. I'm going to avoid using Rust at all costs because I get zero joy out of using it. But if someone said you have to write a program that's going to have a whole bunch of memory and people are going to attack it, and if you get one memory bug, your wife dies, I'll probably choose Rust. There you go. Holy stacks. So next time if someone says Rust is too complex, remind them it's not Rust. It's just a good software engineering. It's a bit pretentious. I'm just throwing that out there. I would argue that if you build a CRUD app in Rust, you may not be doing good software engineering. You may be doing fun software engineering. Okay. I'm just saying it's a bit of Oh, that's not hard. You can't have good software engineering without a garbage collector. Everything in Rust necessarily complexity for all applications. I know. Again, there is a subtle suggestion here that any language with a garbage collector is therefore not good because it's not good software engineering. There's a whole slew of things. I think I hate Rust a little bit more now. Yes, I don't like the conclusion of this, which is that there are good principles within Rust, but those good principles within Rust will make it much more difficult than other languages you are likely to work with. Boom. I don't think anybody's going to argue with you, and I think you're going to get a lot of high fives. And then you can say that I think those trade-offs are worth it because I can write code that I think is better. Bing, bang, boom, dunk it, right? There you go. Anyways. I will say this, though. When Rust really kind of hit the scene about 3.5 years ago, I really enjoyed it. When Rust first hit the scene, I thought the people that were using it were just annoying, and I made fun of them a bunch. And then I used it, and I said, oh, wow, this is really, really fun. And the reason why I really, really liked it, I'm going to be honest with you guys, is that I always really liked writing C, but I always found it a huge pain in the ass with some of the casting and all that. And I felt like I just had a lot of the modern niceties with all the power of C. And so I wanted to keep on using Rust for a while. But then as I used it over the course of 2 years, both professionally and as a hobbyist, I realized I did not like it. And I just became less and less, I just didn't have any joy writing it. I just got angry. You know what I mean? I think anytime you program for 10 hours, you eventually just get to the point where you're just like, I don't like this anymore. And you just want to take a break and just not think about programming for a while. That's fair. 10 hours of programming just makes you tired. I found that when I programmed Rust, I had the same experience, except for it only made it to 3 hours. And I'd just be like, why am I always getting frustrated? I just don't seem like I just don't have that passion. But when I programmed Zig, I felt like I could just Zig pretty hard. I feel like Zig I can go for 10 hours. I just enjoy Zig. And I don't know why. That's just me. And I know people that have the exact same thing except with Rust. So, bada bing, bada boom. The name is the Primeagen.